Hi, everybody. Today we're going to talk about software testing really from a beginner perspective. So let's go ahead and get started. So you may think that software testing is just really clicking a bunch of buttons, but in reality, it's a lot more than that. So, what we want to do with software testing is find gaps between what the software does and what it doesn't do. And really, that's the delta as it relates to finding defects or things of that nature. So we definitely want to identify and find the gap. So there may be a set of requirements in an ideal state, and you basically are comparing the requirements against the expected output. Now, that doesn't always exist. And so sometimes you have to perform your own analysis in order to kind of determine either what's working or not working. In addition to that, part of the job of testing is to reduce risk. So we want to make sure that the risk is reduced before it goes into production. So we want to focus probably on the highest and most critical risk items first, and then we kind of work our way through it. So me as an example, I like to categorize test cases in high, medium, and low buckets. And so I'll execute the highest first, then I'll do the mediums, and then I'll do the low, because really the highest risk ones are often the most important. And honestly, we may not get enough time to test all of them. And so you don't want to test low ones before you test the high ones, as an example. And then in addition, software testing and really quality assurance is to verify and validate, did we build it right? Is this the right thing that our customers want? So sometimes we have to play devil's advocate, if you will, to figure out if this is really what the customer wants. And in other situations, is this what the customer really needs? So there are four basic test levels. So there's the unit test level, which is a really small piece of code. It's done in isolation. These tests are pretty much all automated, and they're usually written by development teams. So they only test the piece of the code that they developed, and that's it. Then we get into more integration tests. So you're going to take one piece of code and another piece of code and make sure that those components can talk to each other and work with each other, and that those connect and operate properly. A deeper level of testing is either system or end-to-end tests. So you want to take basically all parts of the code, you want to string all the integrations along, and you really want to make sure from beginning to end that things are working properly. So for example, with Amazon, you want to set up your account. You may add billing to your account. You may add where you live in terms of location. You may find a product like a computer, and you really want to make sure that from your name, from what you ordered, making sure that it gets billed properly, and ultimately making sure that it gets delivered. So that would be an end-to-end test as it relates to Amazon. In addition to that, there are some tests, and a lot of the business will do this test, but we want to make sure from an acceptance perspective and really from a business standpoint, does the test do what it needs to do? And is the customer going to have a positive experience as it relates to this test level? So we want to take the smallest component to the largest component and make sure all those components are covered as a part of the testing strategy. In addition to that, there are functional tests. Does it do the thing? If you click the button, is the right screen or the right output going to appear? Are you going to get pass fail on some of your behavior? In addition to that, you've got other components that are more non-functional in nature. So, for example, speed, security, usability, and accessibility. a big aspect of non-functional is mostly tied to performance, right? So is the system under load going to respond appropriately, or are their users going to be frustrated by that? So these are the really two areas, focus areas, and the different questions that you have to ask to understand the feature in order to be able to test the feature. Now, there's a lot of jargon out there. There's a lot of things. You may get overwhelmed as you really start to understand what software testing is, but we've covered the basic four, right? Now, there's other levels, but from a foundational perspective, you want to make sure that you're focused on primarily integration testing. I know this didn't mention it, but API testing. So you want to make sure that your APIs are working properly. End-to-end testing, certainly critical, and usability or acceptance testing. And then those are the functional ones. And then you have the non-functional. And probably out of the non-functional, you've got security and you've got performance. And those are probably your most critical non-functional ones as it relates to that. In general, when you're doing testing, you're going to most often do three things. You're going to build test cases. So you're going to take information from the requirements and you're going to design your test cases to test these features. You're going to, once you built the test case, you want to run it in the proper environment when the code has been deployed, and then you want to record and determine what happens. So are the expected results matching what you expect to see? If they are, then that would be a pass. If the expected results do not meet what you expect to see, then you would be a fail. So if you fail a test case, then you're going to move to the next level and you want to create a bug or a defect, for example. So you want to provide the exact steps of how you've reproduced the issue. So step 1 through step X. Then you want to provide what you expect to see and what you actually saw. In addition to that, you want to provide information around the environment. You also probably want to provide screenshots. You want to provide perhaps what user you tested it with. And so you want to add as much information in this report as possible so that the developer has the best information and they can figure out what happened from that perspective. And then in addition to that, you're going to have different cycles. So you're going to create test cases, you're going to write them, you're going to execute them, you're going to log what happened. If there's a fix that the developer does, then you're going to get a code deployment and you're going to retest that, make sure that's working well. In addition to that, there's other test cases that you probably generated previously on previous features. So you're going to run those in a regression suite. And then if everything looks good and there's no major issues, then you're going to sign off and you'll move to the next release as an example. So there are 4 parts of a bug or a defect. And the defect, I really can't emphasize this enough. A lot of times the tester will skip parts of the step. And then it's not a good defect. It lacks information. The developer gets frustrated because the tester didn't put all the details in it. So now the developer has to go back to the tester and ask them questions, especially if you can't reproduce the problem or the developer doesn't reproduce it. Then it's going to be a big problem because then your bug effort is wasted. And so a lot of times I like the testers to make sure they can reproduce it first before the bug or defect is generated. So you want to have the exact steps in the order of the steps. You also want to provide the developer for the information as it related to what you expected to see to what you actually saw. And then you want to provide other information such as browser, OS, environment version. You also may want to get logs in Splunk, for example. So providing as much detail, you also want to provide in what data you used and probably when did you execute this test on what software build, for example. Now, here are some basic things that you need to, if you want to dive into software testing and some of the more detailed information, you can do things like, for example, take an app, find a few bugs, write those bugs as a real report, for example. In addition to that, it's important to learn some of the basic vocabulary and so that you're basically talking the same language. And a lot of times, and what I've done some previous videos on, is testing certification. So it may be a good point to start there with some of the certifications, because that way you know what a test case is. You know the standards around a defect. You know what a regression test suite is. You know the difference in a defect as it relates to severity versus priority. So some of this basic vocabulary and terminology is super important because it is a different language, right? There are different terms. There are things that you're going to need to know and understand as it relates to software. So if you can talk the same language as your peers and your developers and your product owners, then you're going to be that further ahead. In addition to that, one of the critical things of software testing is really the planning and the analysis part of it. And that involves writing test cases. If you were going to take a large application like Amazon, for example, they're going to have probably thousands of test cases, right? The other thing that's really important is to make sure that you're writing these test cases in detail, right? So you want to make sure, and I really make sure that my team does this, is they're writing the exact steps. They're putting the information as to what data that they're keying in, and they're putting what the expected outcome is. So I really like testers to write detailed test cases. Now, I know this is a large effort and undertaking, but there's a few reasons why I want the tester to write detailed test cases. For one thing, it helps if another tester picks up your same test case. For example, if you take PTO for a week and go on a vacation, then you want somebody to come in and I need another team member to execute those test cases. Then they can pick up yours, and if they're super detailed, run through it, and it makes their life a lot easier. Or if you decide to go work somewhere else or go work in another department within the organization, then those detailed test cases are helpful. The other thing that it does, especially if you're building out regression suites, other people can take and run those tests and really understand how the system operates. So for a lot of beginner testers, what I do is I give them access to the application. I give them a series of regression test cases, and I have them run those multiple times to make sure that they're comfortable with the system and the application. And then another important aspect of it in terms of having that level of detail is that you can give those test cases to an automation engineer, and they can take your test cases without really needing to understand all the details of the system, and they can automate those based on the steps that you have provided. And that saves everybody a ton of time, because otherwise the automation person is going to have to come ask you questions or somebody else. And that really just makes things a lot different. So if you do some of these basic things or understand some of these basic principles, then you're going to be that much further ahead than somebody that's coming in but not doing the same things, as an example. So I really stress this over and over again, is that the job is a mindset thing. So if you have the right analytical skills, if you have the right mindset in order to, you want to make sure, for example, that the product is a high quality product. And so you're not going to skip on this one. Looks okay, but it really doesn't work as best as it could. No, you want to have this perfectionist attitude and this high quality mindset. So it really takes the right mind in order to be a great software tester. And the mindset is not something necessarily that I can teach. For example, I can teach you how to write a test plan. I can teach you how to write a test case. I can teach you how to write a defect. But if you don't have the right mindset, and if you're not determined enough to make sure that this is a high quality output and product, then I can't really teach you that from that perspective. A smaller part of the testing approach and really process as it relates to being a good tester, certainly we are using tools, right? So we often use tools to put our test cases in. We often use a tool to create a defect. We use tools to do automation testing, performance testing, security testing. So there's a suite of tools that we use, but a lot of that, again, is learning based. So if you can learn it and you have the aptitude, then you're going to do it. But it's all about the mindset. So just keep that in mind as you are starting your testing career. So if you have the right mindset, there's really very little barrier to entry, right? While a lot of companies want to have you have some sort of computer degree, it's often not necessary. So I've seen people who have a history major or an art major. I've seen these people be tremendous software testers because they have the right mindset and the right mentality. And if you think that software testing is just clicking a bunch of buttons and making sure that it works right or not right, it's a lot more than that. And the analysis, the mentality, the mindset, the determination, you have to deal with developers who think that they know everything. You have to deal with other people, maybe in the business or a business analyst. So it's a lot about communication, coordination, and planning. And it's very little about clicking on buttons. And test execution is really the smallest part of software testing in general. So testing is a craft. It's not a checklist, right? So you have to analyze things. You have to learn how to find gaps. A lot of times requirements, for example, aren't going to be well written. You're going to find issues that maybe nobody thought about from that perspective. If you're trying to approach it from a customer-centric perspective and the flow of the application is not done well, then you've identified a gap and an issue that may need to be addressed. And it may match all the requirements. But if it's not functional and if it's not usable, then the customer is going to get frustrated and they're not going to use the tool. They're going to go to a competitor or find another tool that works better to meet their needs, for as an example. So I just wanted to give you a good foundation testing for beginners. I hope that you've enjoyed this video. I have a lot more content on the QA revolution. We talk about basic things like testing fundamentals, understanding test case planning. We do a lot of things around testing that's just more than clicking buttons. So I have a lot of videos around that. I also have QA career focused information, how to build a resume, how to land a job, steps to getting hired as an example. So I like to focus on the career mindset because I've been in software testing for 25 years, so I really know and understand what's going on, and I've seen the evolution over time. In addition to that, there's a lot of focus around manual automated testing, so I spend time on automation. And really, some of my latest stuff is more AI. How can we leverage Claude to help us do better software testing, planning, execution, test case creation, for example? What tools are out in the market that could help us from that perspective, especially as it relates to AI? So I hope that you've enjoyed this video. I have a lot more out there. I'll be publishing more videos as it relates to software testing. Please subscribe to my channel, and I look forward to seeing you on the next video.